So let's look at the first problem, and this problem is essentially, let me just have a little annotation here. Okay, there are ions, and iron oxide is, I'm circling iron oxide in a different forms. Can you guys see those? Right? So what the overall concept before we go to the actual mathematics here is this diagram shown up here. So ions, this is actually our civilization was possible because we know how to make the rust, right? Iron oxide, the ugly brown looking stuff. You can get rid of the oxygen to reduce it to make an iron. That's we are still in the, I think, the Iron Age. So there are different forms of iron oxide. And the question is, I want to know what's my delta H from FeO to Fe. So this is a question there. Can you calculate Fe oxide to Fe? And this is a reaction. And what was given is a bunch of reaction was given to here, and you need to just figure it out, like how this is all related. So this is your final destination, and this is your starting point. And let me give you an analogy that I used it last year. So I'll put this slide up so you can just sit down and relax. So it's enthalpy is a state function. What that means is it doesn't matter how you get there, as long as you keep track of each step and you track of delta H. And here's a kind of a situation that you are in the New York City. I want to know my delta H going to the Albany. That's my delta H. You can calculate that directly if it is possible. If the information is not given, but I know what's my delta H from New York City to the Allentown in Pennsylvania, to Syracuse, to Albany. Somebody make this detour, right? If you add it up, delta H1, delta H2, delta H3, that will summation of delta H is same as just delta H in the same direction. It's just like a vector summation if you remember your math class before. So now you can see that, okay. So I think that the one that I shown up here is this, right? So I want to know FeO becomes Fe, but this one, if you look at the reaction down, FeO becomes Fe3O3, so I can make a detour. I'm in the Allentown. The Allentown, I can go to the another different kind, Fe2O3, which is, I guess, a Syracuse, and that Syracuse will lead to the Albany. So I can go from New York City to Albany by making detours in 3 ways. And the one thing is, they give you, I want these changes, not the left to right, but right to left. And if you look at take the direction changes, all you gotta do is just to make a sign changes up there. So those are your guiding kind of the roadmap that you wanna do. And then let's crack each one of them by one. So let's go back to the original problem. Okay, so this is the original problem. And let me color it. So this is where you are. So let me get rid of the rest of them here. So this is your starting point. Your destination in red is right there. Right? So I want to go, and obviously I need to go to the backward. So this is the one I have to do. But I need to make sure I'm starting with 1 FeO, and this one has a 3. So what you need to do is, I have to multiply by this one by 1/3. And knowing that that's a minus sign, so you have to multiply by -1/3. And now you essentially, you can in your mind that you can write on the side, say, okay, this one is FeO, 1/3 CO2, and 1/3 CO, and 1/3 Fe3O4. Okay. For the convenience, I'm not going to really I'm just focusing on the oxide component. So now even I'm not going to even write it. But okay, so I shift my focus from here to here, which is a 1/3 FeO3. And where do you have FeO3? Here, right there. But I don't have 1/3. I have 2. So what I need to do is this. My second stop, this one I need to multiply this one by 1/6. Okay, so and then this is going backward, so therefore it is a negative. Okay, so by doing so, what you have at the bottom, the equation written in the black ink is now become 1/3 FeO3O4, and because you multiply by this one is half Fe2O3. Right? So I just keep track of the iron oxide different form. Right? So because I generate new term, I chose this one to make sure this one appears in this side, and then that one is going to generate Fe2O3, which is a half term. And where do you have an Fe2O3? Right there, and but is so I need a multiplication again, which is this one has to be multiplied by 1/2. But this time I'm just going to the same direction as what delta H of value is shown up in the corner. So therefore I don't need a reverse sign. I just do the same sign, but by doing so, I'm generating Fe2O3 half, and then this one becomes actually Fe itself. So then okay, I start from here. I start from FeO, and I ended up being that, and that's an equation. And then if you have an extra time, you guys can work on the CO2 and CO balances. You will work on. So what is there now is this my conclusion that I have here. So what I need to do is, this is a step, if you want to say 1, 2, 3 steps. Each step has to be multiplied this number by half, this one by -1/6, this one by -1/3. So that's how I choose those numbers to get this where you are. So you can follow me now. Where okay, this is a backward reaction and this forward reaction. This is all reverse, means sign change of what is value shown up here. This is the same direction, and then all you gotta do is just add this one up, and you'll get this numbers. So it's due to the interest of time, I'm just gonna move on to the next problem, which takes 20 minutes. Exaggerating, 20 minutes to solve it. So this one is not bad. You just make sure that this one, enthalpy is a quantity that is a state function. It doesn't matter how you get there, whether you're making 3-step or a single step. The single step can be broken into 3 steps, and how you choose the right sign and the right number is what you need to figure out.